welcome back. We are here with another episode. I am Jaden Behrens, and I am joined as always with my co-host Jessica.
Hello.
Today we have a guest star on our show, Sean, the Director of Engineering here at RLS, and we are going to be doing a Myth Busters episode.
It's gonna be fun. Hello, everyone.
So Sean, if you just want to introduce yourself a little bit and explain what you do here.
Okay, well, hello, everyone. I'm Sean Keller. I'm the Director of Engineering at RLS. I have been with the company since its inception. I've been working on the product for 12 years now. So I've seen it through R&D and almost 10 years now, right, in the market, which is exciting. I've seen all of the ups and downs and in-betweens of the development, and looking forward to debunking a few myths today.
Yeah, a big core philosophy here at RLS is engineering and R&D. That's how we started. I know we mentioned that in other podcast episode, but this is a very highly engineered press fitting that we continue to improve and expand upon in our product breadth and with our tool and jaw compatibilities, continuously keeping up with codes, standards, industry changes, all of those fun things, and that all falls on Sean's back. So good job, Sean.
Well, I mean, we have a great team within the engineering group and the quality group. Right, and yeah, just making sure that not only we provide the best quality product we can, right, but that we're taking into account, as you said, the market shifts, feedback from the field. The sales team is an integral sort of conduit to engineering ideas and stuff like that, and they bring to us, feedback from contractors who are using our product every day. And without that, we don't have insights into how we're going to provide the best product portfolio we can to our customers, to our end users, and in the end, that's really what we're looking for, is to make their lives easier.
Yeah, exactly.
Do you want to share some key challenges and breakthroughs in the process of developing
Yeah,
RLS
because
bids?
this product would not have any of those.
Yeah, no, without boring everyone to death with the backstory, the biggest challenge, at least in the early days, was making sure that we were getting a consistent seal with our system. Originally, we were looking at using like a hand toggle tool, which was inconsistent at best. And so, changing the profile to utilizing a mechanical or a battery-operated tool is more in line with the water press side of things. Helped make it to where we could press on the O-ring and get a better seal, as well as moving up in size. We were pretty much tapped out at 7/8 with the hand toggle tool, and going inch and eighth, inch and 3/8, and now into our XL sizes would not have been possible without making that adjustment. So that was a large hurdle in the early days, and then just getting sort of code acceptance, code approvals as a new product, right? Probably talk about it a little bit here in a little bit, but the product approvals with codes when you have something that's brand new, right, and has no benchmark, has no baseline. So probably those two things were the biggest challenges, aside from getting people to accept that our product is safe, strong, and reliable.
I have a question. So since there wasn't any standards, as you mentioned, for this product in this category, how did you figure out what to test for or to test to come up with something to present?
Yeah, so it was a combination of a couple of things. We did have some assistance from some outside consultants who were familiar with the space and kind of maybe what tests we should look at. There was a group we worked with out of loosely affiliated with U of I, Creative Thermal Solutions, who helped set up our third-party testing from a pressure temperature cycling, vibration, freeze thaw, etc. and trying to do what we called at the time like our 4 seasons testing. But as it relates to HVAC fittings, there's a handful of standards out there, but the 207 standard was identified as one to test, and then we kind of built a test framework around that to try and give as much exposure to the fitting as possible, as much relevant exposure to the fitting as possible, that would be in line with what an end user or an installer could experience with their system.
Okay, yeah, because in our last episode we went through all the testing, but I wasn't here for how we figured out what testing we're doing.
Yeah, the end goal, of course, is to try to break the fitting, right, and try and figure out what it can hold up to, right, and take it well beyond anything that anybody would reasonably expect. And that's the fun part of engineering, is trying to break stuff. So blow stuff up and break it. And so we tried to put the fitting through as much as we could to try and build that trust and acceptance.
Yeah, absolutely. So one of the fun things here at RLS is experiencing the polarizing topic that it is. If people love it, they hate it, they trust it, they don't trust it, it needs more time out there, or it doesn't work, or I'll believe it when it holds 600 psi, or whatever the hurdle is for someone in their mind. And you have coined yourself as the rain cloud around here.
I am affectionately known as the office rain cloud, yes.
Yes, because he meets everything with logic and testing and data and thinks very rationally, whereas somebody on the marketing or sales team, I think we're more emotional thinkers.
Sure.
And so when you hear some comments like press fittings are not as durable as legacy traditional brazing methods, what makes you think or feel comfortable that it is?
So the challenge with any new product, right, is unlike legacy, it has no longevity. And so with our product, having again been part of that testing, it was in development for nearly 4 years to get the initial launch. And so in that time, I must have blown up hundreds of pieces, done leak testing, helium leak testing at 600 psi on hundreds of pieces, to the point where I would actually hold it in front of my face to check for leak bubbles. So, I've literally put my face on the line to check for leaks, and I can confidently, knowingly stand,
Still here?
I'm still here, right? But it's one of those things where I've seen what it can do, and it's conveying that to the end user, to the call it the legacy installer or someone who's just unfamiliar with it, and all the best we can do is show them the data. I think as far as manufacturers go, we're about as transparent with data as anybody out there. We want people to question it. We want to be able to show people that this does do what we say it does, and does it every time. And so when someone says, "Oh, it can't do this or it can't do that," my response is, "Well, let me show you." And that's the fun part of engineering, right? Is to demonstrate, to show, that what you've made, what you've designed, what we've designed, stands up. And I think we're getting to that point now, here almost a decade in, where there's enough
Evidence.
usage and there's videos and there's people on social media who are using it daily, if not weekly, and it's one of those things where you start to build that trust, and it's all about trust, right? Especially in a high pressure gas market. So
Yeah, it's funny because it's so easy, it's fast, it makes so much sense. However, that's not the main component here it's trust.
Yeah, it's all about trust and trusting that this new and press fittings are disruptive. I mean, it was disruptive on the water side when those were first introduced, and it's just as disruptive on the HVAC, gas side. And the proof is in the pudding, and we have the data to support it. We have the videos to show it. We always you all invite people in to see it, and we're always happy to demonstrate the performance side of the fitting.
Yeah. So one of the things people ask about a lot, and it's a differentiator for our product, is that our fittings are soft copper. Why?
Well, I think there's a couple reasons. One, I think originally goes back to how we originally designed it. There was, but beyond that, call it the flexibility or the ability of softer, malleable metal to resist system pressure, not necessarily the pressure, but for example, vibration,
Fluctuation.
right? Yeah, and you've got vibration testing, for example, right? If you've got a rigid connection, if you've got think about like a braze connection, for example, right? There's not a whole lot of flexibility under that sort of loading, whereas a softer material will be able to sort of absorb that shock a little bit more. One thing we point out when we do our burst testing is that the area between the O-rings will expand under pressure, right? But the area within the press bands doesn't. And so you're able to sort of move where the stresses are being seen within the fitting to an area that's away from the connection point. So it helps to kind of
Displace turbulence
well,
into the right areas?
It helps to move those stresses and strains away from the primary connection point, and so it helps with the strength and performance component of the product. So yeah, it's a couple different things. It's probably a legacy thing as much as it is a performance thing. So
Yeah, just a choice that was made. And
I think there was also a way to differentiate from what was existing on the market, which is all hard anneal press fitting, water fittings and that sort of stuff. So yeah, so again, it's kind of it's a two-pronged thing from a legacy perspective and a performance perspective.
yeah, and then in our case now, too, as so many different press tools come out, hit the market, there's all these different tools, all these different jobs that you can use to press our product, and an advantage to our fittings being soft and have been annealed is that we're allowed to offer a lower power, lower kilonewton tool, which usually equals less expensive to press our fittings full product line for the most part.
Yeah, and having the circular press, right, being that we're touching 360 degrees compared to a traditional press profile, you need that softer material to move, right? If you're trying to circular press hard material, at least the way that we do, it would create a significant amount of flash at the top of the press that could potentially cause issues. So having that soft material does allow not only lower pressure tool platforms to press it, but or lower force tool platforms, but also makes our circular press profile, I guess, easier, on top of the fact that we can then work hard in our press bands in place from an annealed state. So
Yeah, so the important part, the strength part, is hard.
correct.
Yeah.
Correct.
So here's a big question is, and this is one we hear a lot now, is what's the reasoning behind 1 seal, 2 seals, 3 seals? What's the point? What does 1 seal do? Or what is the integrity of the seal within this joint? Because if we're pressing on to the pipe, our design is, that's where your strength is coming from in the joint, keeping it together. What's the seal doing?
Yeah, so the seal is holding in the gas, right? That's your joint, that's your seal integrity. Without the gasket, it wouldn't hold much as far as the gas pressure is concerned. Now, 1 O-ring, 2 O-rings, 6 O-rings, you know, the O-ring as it's designed is meant to, again, hold the gas back. Now, for us, we've done extensive leak testing because it is a point of question a lot. And recently we just completed our ISO 14903 certification, which is at present the only globally recognized joint tightness standard out there. Which, to simplify it, it sets a specific allowable leak rate, which is in the order of magnitude of 10 to the minus 7. So that's six zeros.
I think I
and
tried to say
one.
that last time.
And so it's 6 zeros and a 1 would be 10 to the minus 7, for example, as it relates to a leak rate. And so to, again, put that into perspective, that's like 0.0001 grams of refrigerant, basically is kind of what that's equivalent to. And so for us, you know, we've subjected ourselves to this testing, which not only has a baseline leak rate, but then it puts it through stress tests, so vibration tests, cyclic fatigue test, and then it tests the leak rate after that test, and it compares it to what it was before, and it has to be within a certain threshold to be considered compliant. And so we actually just completed that testing. Everything we sent passed 1/4 inch through 2 1/8. So, which is great because it positions us well for the emerging fluids and stuff like that. But, you know, when a system is designed well, the O-ring itself the single O-ring itself is sufficient to meet the system requirements. And this testing that we just did demonstrates that. You know, for our own internal things, we do testing at 500 psi helium, which is 3 times as high as this ISO standard requires, and we maintain the exact same level of leak integrity, joint integrity. And so, for us, the way our system's designed, 1 O-ring is more than anyone needs for
This use.
Yeah, for proper seal for proper system usage.
So you brought up something that I like when you nerd out on it, but it's like probably the number one question is these fittings leak.
Mm-hmm. Yes.
Can you like talk about that?
Can I talk about leaks?
Yeah.
Sure, I guess. Well, the key thing to recall is that everything leaks. Everything. Your braze fitting leaks. Your soda caps leak. I mean, you know, if you leave a soda covered long enough, it's going to be flat as all get out. Everything leaks. Everything that has a seal leaks. And so there is a sort of designation or a point of diminishing results or returns where we can equate our leak rates to relevant refrigerant levels or amounts. You know, and again, the testing that we've done has shown that it would take thousands of fittings to leak 1 gram of refrigerant or 1 ounce of refrigerant. Hermetically sealed is defined in many standards as 3 grams per year of refrigerant, and I believe the EU F-gas laws echo that. And so now that may change as the markets adjust, but knowing what we are able to maintain or what we're able to achieve with our system, we are, again, orders of magnitude. You're talking 100 to 1,000 times tighter, tighter than what the requirements are for these ISO standards.
Yeah, because that's something. It's either like the point of concern,
Mm-hmm.
or the point of I don't believe or whatnot, but the reality is, like you mentioned, everything has a potential to leak.
Everything does.
It's just what is the acceptance.
Yeah, I mean, if you take like traditional flare fittings or compression fittings, right? They have a leak rate. There is a measurable leak rate that they will have, in a properly made flare or compression fitting versus an improperly made flare or compression fitting. It's wildly different, right? Just like a properly made braze fitting is wildly different than a properly made braze
properly
fitting.
installed RLS
And
fitting.
same thing with the properly installed versus an improperly installed RLS fitting, right?
Yeah.
So there's for us, again, from what we've been able to test and demonstrate, third party and such is again, the product and our fitting is more than capable of handling any sort of system that these might go into.
Yeah. Okay.
When pressed correctly.
Well, that is the assumption.
Prep before you press.
Some of the stuff we've seen come through the warranty house, it's interesting to say the least.
Yes. We try not to pull many of those out because we don't want to embarrass people, but.
Well, no, and people, that's the thing. When you've got a new thing, I'll have calls. People call me and say, "Well, this is like okay, what do you got?" And we'll talk through it. And there are times where people have pressed it wrong, and they will only realize it after we've talked through it on the phone, and they go, I feel silly." I'm like, "Don't. This is new. Like, this is pressed differently than anything that you probably used to. Don't feel bad about." That it's there's a learning curve with it, and we expect that. I expect that, and so in the end, it's just about helping people get to that point where they're seeing the benefits that we know they should.
It's like, I always say, don't short the shortcut, because like this is already an efficiency within your installs. Don't cut these little corners and make it even more efficient in your mind.
Exactly.
It's going to work perfect if you follow the regular shortcuts, directions.
Right.
You brought up XL, so I want to talk about that a little bit.
Okay.
How long it took you, and what was like
Too long.
the biggest challenge with XL?
So.
Well, first and foremost, we're the only. It's an industry exclusive size range
Correct.
of inch and 5/8 and 2 1/8.
Yes, the 12 new SKUs that we have, the 6 for each size, 4590 coupling T and 2 reducers for each size, is a industry. It's exclusive to our system. How long did it take? It took way too long. The concept started we started the project in I think 2019. Now COVID had a little bit to do with it. That kind of sort of derailed / restarted the project because we did experience some initial manufacturing hurdles, and challenges around trying to move, an eighth of an inch of wall. Those fittings got nearly a quarter of an inch of material just in the wall on those sizes, and that's the thing when you get into these bigger pieces, they still got to hold the same pressure as our smallest one, right? So our quarter inch will go up to over 6,000 psi on its own, and we need the 2 1/8 inch and 5/8 to do the same. Not go that high, it won't go that high, but they'll still hold well in excess of 3,000 psi. And so for us, it was overcoming the jaw challenge. It was originally going to be on the smaller platforms, or on the smaller 32 platform, but again, moving that much metal, even in an annealed state, is challenging, and you've got to press it deep enough to get the pressure. And so, there were a couple jaw iterations, there were a couple fitting iterations, but we got there, launched it earlier this year, right? And I know that there are some installers who have been able to take advantage of it, and from what I understand, it's been a positive experience. So I would expect, hopefully, that sort of sector of the market to uptake it more and it to become more prevalent. So
that's the goal, is to keep everything consistent amongst our lines. And when you're working with something so much larger, nobody has created jaws this large except maybe on the plumbing side. But for us, with our press profile and our ID, it's not easily replicated.
Yeah, and with plumbing fittings, like larger plumbing fittings, you know, the press is more of driving that grip ring down into the metal than trying to displace the metal itself, right? The strength of a larger plumbing fitting that utilizes the chain system is the grip ring, whereas our strength comes from the metal to metal connection. The seal is the O-ring, but the strength is that metal to metal displacement. And so moving that much metal and getting it to maintain that strength is one of the largest challenges.
Yeah. Good job, Sean.
Thanks.
Team.
Yeah, we did a great job. So we overcame.
So are there any upcoming projects that you're working on that you can give us a little secrets?
So I'm pretty sure I can't go into details on certain things. Joel might kill me. But there are a couple things we're working on for the upcoming fluid transition to A2Ls and A3s at the OEM level. There are equipment changes that will require new fitting combinations, new size combinations that we don't currently offer that we are working on. We are additionally working on new sizes for our international markets to again better service certain areas. It's kind of an in-between size, or actually no, it's a step up from what we currently offer in those markets. And so it's in a way it's kind of like the XL sizes and how those should help support kind of a broader, larger commercial side of the market. You know, commercial installs, larger HVAC system installs, etc. So we've got that ongoing, and there are a couple of job projects we have in the works now too, which should provide more flexibility to
Larger product breadth.
well, yeah, and yeah. Again, it's just
Always go
expanding-
back to the marketing words.
Yeah, it's expanding the product portfolio, right? Like we're trying to offer again as many components and as many pieces as possible to outfit our end users. So
Yeah, so always something going on, and not everything comes to market, but we try
Right.
to figure out about everything that we can or exhaust ideas.
yeah, and I mean there are a couple other things that are on the back burner for you know future consideration, right? And as I said earlier, the sales team comes back with a host of things, and so we filter through-
Engineering loves sales.
We do. We get along very well. Yeah, and then as I kind of alluded to it earlier, but with the A2L
Yes,
switch.
talk about A2Ls.
Yeah, so I know that's a big thing that comes up in our weekly sales meetings and stuff like that. Which again, I won't bore anybody with on that. But we did just complete our ISO 14903 testing. Again, everything's passed quarter through 2 1/8, and so the next steps with that is to get our listings updated to include the new fluids. We've already done the compatibility testing with the main A2L constituents, so 32, 124 IFCE, etc. We got the 454B specifically tested, even though that would have been approved via constituents for the blend. But yeah, so I would anticipate within the next 4 to 6 weeks having that listing updated and us good to go for the market transition for the A2L fluids.
Yeah, this has been a huge project, or at least time-wise too, on making sure that we're staying current with this market and with this shift and being ahead of it, being proactive instead of reactive for it, because we also know a lot of people will be like nervous to invest in this system or convert their teams to it if they didn't know it was going to be approved and certified for the new constituents and fluids coming out or being mandated to come out.
Right.
And so Sean and his team had to prepare hundreds of samples, correct? Or 100 plus samples?
Yeah, I think it was 120 or 130 samples, just because we had all the different tests that it had to be subjected to. But yeah, across all of our SKUs, again, smallest, largest, and a couple in between to kind of be representative of all the different configurations, and then 5 or 6 samples of each. So it was it was a large undertaking. Shout out to Grant and Max for helping put those together. So appreciate that.
Yeah, but with testing places, testing people, but it's like a turtle race.
It is.
You know, we're over here, we want the 100-meter dash to happen with testing, but that's not the reality. It's like a turtle race.
It's a marathon, not a sprint.
Yeah, exactly.
It took 7 months from the time that they received the fittings to complete the testing. So
yeah, but it also is a testament to the accuracy and the quality of the testing that's occurring. It's not just we paid you money, give us the certification. They're actually also trying to make everything fail and push it to its limit and make sure that in the field it's going to hold up and be compatible like we say it is.
Yeah, and the particular lab we use is one of the only labs that we can actually find globally that is set up to do the ISO 14903 test in its entirety within its scope of work. So it did take a while to actually source the lab too. So that was an additional challenge.
Yeah, but we are very excited to announce and say that we passed, and now it's just in the hands of...
just a matter of updating the documents.
Yeah, just a matter of updating our listing to showcase and provide that transparency and proof that you can go to our ICC listings and look us up and find what we are actually certified for. Always look for the word certified and approved versus compatible. Yeah.
Yeah, compatible does not equal compliance.
Exactly. Sean keeps telling me that.
Multiple iterations of our refrigerant table will be a testament to that. So.
Yes, exactly. Well, lots of things cooking, lots of things fully baked now.
Indeed.
Yeah, wow, I like that one. But one fun thing I want to ask you is through your time at RLS and being a part of this development and inventing a category and testing and pioneering something, really, what has been one of your favorite parts or one of your biggest accomplishments that you really, really, oh, I'm proud of myself. I'm proud of my team.
Wow. Yeah, so it's kind of rare actually for an engineer or someone to be involved at the ground level of a new, especially an industry changing, or at least, you know, an industry like kind of adjusting product, right? And with R&D, anybody who's involved in R&D knows that the vast majority of things you work on don't pan out. And so to have something like this, you know, turn out the way that it has, to see us go from, you know, to get our own place, to get our own building, you know, we're sitting in the showroom now, to see where it's come from, that's probably my biggest, like, pats on back thing, is to see the growth, to have gotten to interact with as many people as I have, and I'm, you know, you both know I'm not a people person.
He lies.
And so, but, you know, visiting, you know, in the early days, I was going to job sites to support installers. You know, I got to go to Boston and Pittsburgh, and it allowed me, you know, out to LA for different things, and, you know, meet different people. I've had the fortune of having tremendous coworkers over the last 12 years plus, and so for me personally, just seeing this go from CAD drawings, which is what I did, that was the very first thing I ever did when I started, was the CAD drawings, to now we've got 120-ish different fittings and you know, tens of millions sold and, you know, installed, and, you know, we're getting, you know, you all were just at the HVAC national thing, and we're getting, you know, pulled into those things. It's like, it's just cool to see something that was an idea changing people's lives and making it better, making it safer, making it easier for them. So it's in the end, it's helping others, and that I got to help design something that does that is pretty cool.
Make me cry. 'cause
I
I'm a
know.
softie. Jesus, Sean.
That was a good answer.
Oh, thanks. Appreciate it.
Felt very heartfelt. He didn't know
Yeah.
that we were going to ask that.
No, that was not on the sheet. So, yeah.
Do you have anything else you want to add?
No, I mean, thanks to everyone who has given our product a shot and continues to use it and finds value in it. And thanks for listening to the podcast. Press Gang, hashtag Press to Chill. What are all the hashtags you got out there?
Hashtag Press Gang.
Yeah.
Hashtag Impressive.
Oh yeah, impressive. Yeah. So.
Hashtag Press to Impress.
Yeah. So, but as someone who tends to work behind the scenes, and I don't get a whole lot of feedback from, unless it's bad usually, which then we fix the problem, right? But thanks to everybody out there who utilizes our product. Thank you, watching, yeah, I can't wait for what's coming down the line.
Yeah, and if you have a problem, Sean will take all of your calls directly at 636.
Yeah.
Great. I already get spam text messages about election things. We would like you to take this therapy. Stuff that's important to Missourians. No. So my stuff gets sold 6 ways to Sunday. So you can find me.
Well, we always do a special word for swag. So if you listen to this all the way to the end, and you comment on our latest Instagram post, HVAC Engineering, we will send you a little swag box.
Woo!
Woot.
Yeah.
Yep.
Well, thank you everybody
Yes.
for joining us.
Thank you.